Acha, so in the last lecture we discussed the different types of FETs, JFET, MOSFETs, and we subcategorized the MOSFET into D MOSFET and E MOSFET, further N channel D MOSFET and P channel E MOSFET. Similarly, enhancement type MOSFET and enhancement type MOSFET is further divided into two classes, subclasses N channel E MOSFET and P channel E MOSFET. We discussed the construction of the devices as well as the characteristics of the devices. And the most important characteristics for the FET is the transfer characteristics. And
सर
this
हमें
trans
ब्लैक स्क्रीन शो हो रहा है,
ठीक है
कुछ
वो
शो ही नहीं है।
मैं कुछ लिखूंगा उसके ऊपर, डोंट वरी.
ठीक है सर।
So transfer characteristics, they are more important because they are used in the analysis of the FET circuits. And transfer characteristics, why they are called transfer characteristics? Because it is a plot between the output quantity and input quantity. The output quantity is the drain current and the input quantity is the gate to source voltage. So here we see how the gate to source voltage control the conductivity of the channel, mean the drain current. So the construction wise, D MOSFET and E MOSFET, they are very similar, but the fundamental difference is the channel. In D MOSFET, channel physically exists from the beginning. If there is no bias, still the channel exists, while in case of E MOSFET, there is no channel. Physically, there is no channel present there. So the channel is induced in E MOSFET, and depending upon the substrate, if the substrate is P type, so the channel is N type in case of E MOSFET. So actually the whole structure is P type, but what happened here, when we apply positive voltage at the gate terminal, so electrons are attracted toward the gate just below the silicon dioxide layer, which is a thin layer, and the electrons are accumulated. So this phenomena is called inversion because the material was, actually the material is P type, but it was inverted into N type just below the silicon dioxide layer. So that was the मेन डिफरेंस, द फंडामेंटल डिफरेंस बिटवीन ई मासफेट एंड डी मासफेट. तो ये जो है ना बुनियादी फर्क है, ई मासफेट में चैनल फिजिकली एग्जिस्ट नहीं करता बल्कि चैनल इंड्यूस किया जाता है, और डी मासफेट में फिजिकली चैनल एग्जिस्ट करता है. ठीक.
यस सर।
आपको स्क्रीन के ऊपर कुछ नजर आ जाएगा, डोंट वरी. व्हेन आई विल राइट समथिंग यू विल सी. So that is the fundamental difference, and this E MOSFET devices, they are used in the digital circuitry. So MOSFET, they are smaller in size and they have very small power dissipation, and they are accommodated, it is accommodated in small chip area. Construction is easy, very high input impedance, which is the requirement. So the major application of transistors, whether BJT or FETs, are amplification and switching operation. So our next topic is FET biasing, which is chapter number 7 of the book. And the question arises, what is the need of FET biasing? So because you are familiar with the biasing, when you are studying in the last semester the BJT analysis, so why do we need biasing? That is the question. Any person, any student, why do we need FET, the biasing? बाइसिंग की हमें क्यों जरूरत होती है?
To start the operation of the
Properly, we have to apply the voltages so that proper currents are established and to get proper operation of that particular device. Now the question arises, why we perform DC analysis and why we perform AC analysis? What is the need of DC analysis?
सर जी क्यू पॉइंट के लिए, ऑपरेशन पॉइंट के लिए.
So DC analysis is performed to
Sir.
establish the quiescent point or Q point. Now understand. So the purpose of FET biasing is to select the proper DC gate to source voltage, what we call it VGS, to establish a desired value of the drain current represented by ID, and thus a proper Q point is established. So this is the need, this is the purpose of the biasing, to establish the proper Q point. Otherwise, if the Q point is not properly selected, then we cannot predict the proper operation of the device, because there are three regions for the operation. Maybe in saturation region, maybe in cutoff region, or maybe somewhere, maybe possible that we may operate the device near to the breakdown region. So to properly establish the Q point, we perform DC analysis. So we are familiar with the BJT. When we perform DC analysis for the BJT, so the major question so in BJT, while performing analysis of BJT, And we know that BJT is the current control device. So the equation that we should know is VBE is equal to 0.7 volt. When you perform this analysis of BJT circuits, BJT amplifier circuit, we should know this about this equation. IC is equal to beta IB, and IC is approximately equal to IE. It is nearly equal to IE. So we should know this approximate characteristic equation while performing this analysis. Now the relationship between IC and IB is linear, and it is assumed that beta remains constant during the analysis. So IC is the control variable and IB is the control variable. This is the control variable, and IB, this is the control variable, and this is the control variable or controlling variable. So the relationship between IC and IB is linear. On the other side, when we discuss the DC analysis of the FETs, so we should know about the relationship between the controlled and control variable, which is according to Shockley equation, which is non-linear, because we know that according to Shockley equation, ID is equal to IDSS 1 minus VGS or VP whole square. So because of the presence of this square term in the equation, the relationship between ID and VGS becomes non-linear. VGS is the control variable. So here, so in the first case, IC is the function of IB, and here ID is the function of VGS. But this functional relationship between ID and VGS is nonlinear. In case of BJT, the relationship between IC and IB is linear. So, as I mentioned, these three expressions, V 0.7, I is equal to beta IB, and IC is equal to IE. And beta is a constant, which is also called the amplification factor. So when we perform DC analysis, we have to keep in mind, as I mentioned, three relationships for BJT. Similarly, we have three relationships, the equations, mathematical function for the FET. And we have D-type MOSFET, E-type MOSFET, N-channel JFET, P-channel JFET. So for the JFET and D MOSFET, for the for JFET and D MOSFET, when we perform DC analysis, we should keep in mind these three relationships. Which are those relationships? I is equal to 0 ampere and according to the Shockley equation, what is Shockley equation? IDSS 1 minus VGS divided by VP whole square, and ID is equal to IS. For D MOSFET, JFET, and D MOSFET, similarly for D MOSFET also, these three relationships should be used. For E MOSFET and for E MOSFET, while performing analysis, we should keep in mind that IG is equal to 0 ampere, ID is equal to IS, and there is another nonlinear equation, and this equation is given by ID is equal to K VGS minus VT whole square. In this relationship between ID and VGS, still it is nonlinear in case of E MOSFET and E MOSFET. So, while performing analysis, we should keep in mind these three equations, these characteristics equation or these three relations. Now, how we find the Q point? How do we find the Q point? The question arises, how do we find the Q point? So, the Q point or the operating point, we have two approaches. One is called mathematical approach and the other is called graphical approach. To find Q point or operating point, we have two approaches. And what are those approaches? Number one, mathematical approach. And number two, graphical approach. it is good. It is good to use when relationship between input and output quantities or variables, oblique quantities, is linear. It means it is complex. Mathematical approach is complex. Number two, which is graphical approach, and it is good when the relationship between input and output variables or quantities is non-linear. Now understand? So what do you think? Which approach should be adopted in our case?
Graphical.
Graphical. Because the relationship between input quantity or the input variable and output variable is non-linear. So then we will go with the graphical approach or graphical technique or graphical method. आप जो भी कहना चाहें वो it is up to you. So तरीकाकार क्या है? ग्राफिकल अप्रोच का तरीकाकार क्या है? ग्राफिकल अप्रोच, we have to plot transfer characteristics with the help of Shockley equation graphical approach lot of transfer characteristics using Shockley equation in case of JFET, D MOSFET, and lot of network equation in which the device is employed. The intersection of these two plots or curves give the solution of the problem and the point of intersection corresponds to QPoint or operating point. And then, so what happened when, so QPoint gives us VGSQ and IDSQ. The coordinates of QPoint are VGSQ and IDQ. Number 4. Once the Q
दूसरे
point,
नंबर पॉइंट का क्या मतलब है?
हाँ क्या बताएं?
सेकंड नंबर पॉइंट का क्या मतलब है?
इधर
सेकंड नंबर पॉइंट
अच्छा
प्लॉट एंड नेटवर्क इक्वेशन इन
अच्छा,
विच द डिवाइस इज एम्प्लॉयड.
पहले आप ट्रांसफर कैरेक्टरिस्टिक्स को प्लॉट करेंगे, शॉकली इक्वेशन को यूज करें, ठीक है ना. और
जी
फिर
सर.
जो आपके पास नेटवर्क, जिस नेटवर्क में आपने एफईटी को इम्प्लॉयड किया है, उस नेटवर्क का आपके पास एक इक्वेशन आ जाएगा. अभी करेंगे एनालिसिस. दोनों को आपने प्लॉट करना है.
ओके सर.
और वो प्लॉट जो है, जो नेटवर्क इक्वेशन है और शॉकली इक्वेशन, दोनों इनपुट और आउटपुट वेरिएबल्स को रिलेट करता है. हमारे पास इनपुट वेरिएबल क्या है? VGS. आउटपुट वेरिएबल क्या है? ID. तो जो नेटवर्क इक्वेशन है वो भी वही वेरिएबल रिलेट करता है, और जो हमारे पास ट्रांसफर कैरेक्टरिस्टिक्स इक्वेशन है, शाकली इक्वेशन है, वो भी वही दो आईडी और वीजीएस को वेरिएबल करता है। इसलिए हम दोनों को एक ही ग्राफ के ऊपर प्लॉट करते हैं। उसकी रीज़न यही है कि दोनों एक मतलब है, दोनों इक्वेशन जो है ना सेम वेरिएबल्स को रिलेट कर रहे हैं, इसलिए हम एक ही ग्राफ पे दोनों को प्लॉट करते हैं।
सही है
अंडरस्टैंड?
सर।
So once the
Yes, sir.
Q point is established, then the remaining quantities of interest are determined. कहानी की समझ आ रही है आपको? तो शाकली इक्वेशन relates ID and VGS. Network equation also relates ID and VGS. So these two equations are plotted on the same graph. अभी समझ आ रही बात की?
Yes.
मेरी लिखाई आपको समझ आ रही है? नहीं, मैं तो लिख रहा हूँ, रफली लिख रहा हूँ, यानी आप समझ आ रही नहीं?